Okay, so good morning, everyone. We're just going to give it a couple of minutes just to allow people to come through from the waiting room. So this morning we're going to be looking at our MSc in Electronic and Computer Technology and our MEng in Electronic and Computer Engineering. So we have our two program chairs, Derek Molloy and Richard Bolger, who are going to both go through the two programs in detail. We also have myself and Jasmine and Anya from the global recruitment teams and also the marketing department of our Faculty of Engineering and Computing. So the meeting will be recorded and sent out to everybody afterwards. And if anyone has any questions about either program or anything to do with admissions, just stick them into the Q&A while they're talking. And at the end of the session, we'll come to the questions and we'll try to answer as many as we can. So I'm just going to hand it over to Derek, who's going to kick us off and start us out.
Thanks a million, Frank. Thanks to everybody for joining us this morning here in Dublin. It's a nice morning for a change. I'm going to work through the. My name is Derek Molloy. I'm a professor, as Frank said, in the School of Electronic Engineering, and I'm the program chairperson for the MSc in Electronic and Computer Technology. Richard is the program chair for the MEng, so I'll hand over to him halfway through the talk. And you'll see that there's quite a lot of similarity between the two programs and the way that they're structured. And I'll talk a little bit about that later today as well. The overall everything is that we're talking about here is on campus. It's an on-campus program, full-time program, a very busy program. These are level 9 programs, so these are a master's program is the second highest qualification you can achieve in academia. The only thing that's higher is a level 10 award, a PhD. So these are significantly challenging programs with full-time requirements, and we prepare you very strongly for industry through these programs. So one of the reasons you might study at DCU is that we're ranked in the top 100 young universities. Possibly even more importantly, we're ranked first in Ireland and 19th in the world for graduate employment rates. Now, these stats don't mean much, and first in the 19th in the world might be, that wouldn't be a great stat if there were 20 universities, but there's of the order of between around 50,000 universities in the world. So this is quite a high stat in terms of its value. So employment rate is huge at these programs. And you'll see as we're going through this, the materials we've designed are structured to prepare you for an industrial workplace environment. They're modern modules and modern subjects that are directly applicable to industry needs. Being one of the world's youngest universities is a good feature too, in that we're flexible and adaptable. And you'll notice that in terms of our size and also in terms of our offerings. They're modern offerings that we provide. To put it in context and to explain why employment is so strong, and again, it's hard to express. Like, Ireland is a small country. We have a population of about 5 million people, which is a small population in global terms. Dublin, our biggest city, is a population of about 1 million people in the greater Dublin area. So it's not a huge city by any means. So quite a small city. You can walk around the city quite well. It's known as one of the world's most walkable cities, which means it's quite small. But you can see this is just Dublin in this slide, and you can see companies that you can recognize as having global brands, from Siemens to IBM to Intel to Nokia, to Workday, to Xilinx or AMD, Adobe, small companies like Google and MasterCard and Sage and Infosys, all around Dublin City. And these are real operations that employ real developers and R&D roles. And you can see DCU is just here, just nicely placed between this cluster of companies that are in Ireland and Dublin Airport. So we're right exactly where you want to be, close to the airport, close to the city, and we have access to many of these companies. So indeed, these bubbles that you see here are destinations for our students, and they're in the engineering and the computing space, and you'll see that that's the type of, largely they're technology focused companies. More broadly in Ireland, and the map that I showed you is this piece, which is Dublin, which is just here. If you go more broadly in Ireland, you can see there's huge numbers, and you're not going to take this in the slides, or sorry, in the presentation, but the slides are available and the recording is available. So you can see just the range of companies that are very large companies that are spread out across the country. So that's one of the reasons that employment is so strong is just the range of companies, and especially the range of companies that are related to the domains we're talking about here this morning. There's a huge number of them. And, our school has been around for a long time, since the 1980s. We're one of the first schools within the university, being a young university. And we've built these programs. We have graduates that over the many years that are in all those companies, and they understand DCU, they understand the DCU brand and the reputation and strength of our graduates. So our school, again, relatively small, which is a good thing, because we have our own buildings and our own spaces in which we deliver our content and give our lectures and have our labs and so on, and where students do their project work. So we have a sort of a center within the university, but that's supported by roughly 24 academic staff, 6 technical staff. And I think what's really important from your perspective, like the number of staff is important, but what's really important is that we're all research active staff that are teaching these modules. So when I teach modules on IoT, my research area is in the IoT space. So that means that I'm using my research team and my work to update the content in my modules. So they're very much research-focused modules. And that's true across all the modules that we offer on these programs. Very much research-led, but also our research isn't just blue skies research where we work in a vacuum. We also engage with industry, and we understand industry needs. And even more importantly, we kind of know what industry needs in 5 years' time, so that we're preparing students for skills that industry doesn't know that it needs. So they're all really valuable skills that we're preparing as part of the modules and as part of the projects you do on these programs. So everything is research-led, and everything we're doing is relevant to industry. We're not focused on industry. We don't do things like Cisco certificates or anything like that. That's not the level that we're at. We're more about making sure that the core principles and concepts are presented so that students can adapt their knowledge when they move to different companies, that they're not tied to one technology from one company, that they're able to adapt things. So that's the kind of area that we're in. So the program that I'm going to talk about first is the MSc in Electronic and Computer Technology. And you can think of this, and the reason there's parentheses here and it says the MSc in IoT is because that's what this program is known as. It's known as the Masters of IoT. So you learn everything about the Internet of Things. And what's interesting about the Internet of Things is it's a different space in that it's really the space where the electronics world and the systems and the computer world meets the software world. So if you're interested in software, if you're interested in knowing more about computer rather than computing, well, this is a very good program for you, because you learn about, you'll see in the modules I show you, there's a lot of programming, there's a lot of modules around blockchain and web application development and on the software side. And then on the hardware side, we're doing things like connected embedded sensors, which are things about how do we build computers that sense the world, that connect to sensors to talk to the world, to measure temperature, to measure occupancy of people in a room, to controlling motors, to opening windows. So it's about how does the software world meet the electronics world? That's the key message in this program. So this is often called the Internet of Things, and the Internet of Things, it's a very big area. It doesn't really exist as one thing, but it's sort of the next evolution of the internet. It's a if you like, at the moment we have the social internet, which is the Facebooks and the Instagrams and whatever social media. That's about humans talking to humans. The IoT world is about machines talking to machines to do something useful. So connecting the world through sensors and actuators or motors, connecting that world to the internet is really what the Internet of Things is about. Now, that might seem like a small thing, but it's huge in terms of the implications. Everything from the way that we manage, smart buildings, the way that we manage smart cities. How do we get traffic through cities more effectively? How do we deal in industrial automation where we want to, industrial internet or industrial automation where we want to do just-in-time manufacturing, or where we want to integrate swarm robotic systems into our industrial environments? How do we manage power where power is not just generated by one power station and distributed to houses, but where we've now got houses that have solar panels and are able to generate their own power at the same time as being able to connect to an EV or, to an electric vehicle, or to power the house on batteries. It's becoming very complicated. Even to do something as simple as domestic power management is becoming difficult. Then there's wearables, about connecting people, or rather the biometric information of people, things like their heart rate blood pressure and things like that at the easiest level to more complicated instrumentation times inside of hospital environments. So how do we do that so that we can maybe detect that somebody is having a medical episode or is having a critical problem? So even in just that one word, wearables, it's a multi-billion-dollar industry in terms of sports science and performance, never mind the hospital environment for patient monitoring. I mentioned smart home, but I only mentioned power. Even in smart home, how do you have it that your house is comfortable, that the sensors, the lights come on when you need them, the heating or air conditioning comes on when you need it? How do you have it so that it's playing the music you want when you get home, or it manages, all the resources? Automated vacuum cleaners are quite common these days. And so you can see here, whenever the word smart is used, smart city, smart home, smart transport, smart agriculture. Whenever the word smart is used, it typically means IoT. It means the Internet of Things, that there's some sort of integration with the real world and the systems. So we're leading in this space. And we're not just talking about the first generation of the Internet of Things was where you had all these little sensors that were sending information to the cloud. And then the cloud does all the smart piece. That's very old-fashioned because that doesn't work well if you've got a lot of sensors. So it's okay if you've got 1 million sensors, but not if you've got 1 billion sensors. How do they all send their data to one point? That can't work. The other problem is that what if the internet goes down? You can't have a situation where nothing works if Amazon goes down. That's just not going to work. So a very big part of what we're doing in the IoT space is looking at disaggregated Internet of Things, and that's moving the intelligence to the edge of the network and creating smart nodes with smart systems at the edge of the network so that we get a quick response time. For example, if you can imagine an electric vehicle with pedestrian detection so that it hits the brakes, you can't have a situation where the pedestrian detection is relying on a cloud service in the middle of the internet, and it takes a long time for the brakes to be applied, or if the internet goes down, you run over the person on the road. What you need to have is the intelligence within the car to detect the pedestrian and apply the brakes before any communication takes place. So where there's low latency or very quick response times, we need to do more advanced Internet of Things. And a very big part of what we're doing, and you'll see this represented in this program and in Richard's programs, there's a lot of machine learning involved in everything we're doing. Artificial intelligence, machine learning has a role in most places, but especially when we're trying to create smart devices at the edge of the network. But we're trying to do it without having a cloud processor. We're trying to do it on small machines or on embedded devices that are at the very edge of the network. So it's a complicated problem. This isn't going to be solved in the next 1 or 2 years. This is a 10, 20-year problem before we even get to the level of being able to do many of the things we would like to do, never mind the things we would aspire to do in the future. So this is a huge area that's not going to be solved straight away. So just to talk a little bit more about the MSc and IoT, again, when we designed this, we worked with industry. We worked with companies across Dublin, and we developed up an industrial-focused IoT program that was designed for industry needs. So they knew there's this IoT concept coming along that's going to change the way that their businesses are going to be affected. So we worked with them to work out what are the best skills that those that their employees need as part of their training. So we worked with industry. We tried to pick out real skills that students would need. We also decided to build a full stack IoT program. And what that means is that we're not just looking at one little part of the Internet of Things, maybe the sensing. We're looking at the sensing, the computing at the edge, the communication, the network security, the cloud engineering and web app development, the machine learning. We're looking at all aspects of the full stack of the Internet of Things rather than just one tiny piece of the Internet of Things. So that's a big part of what we're doing in terms of our program design. And that's important. So you might end up working in one part of that stack because you can't do everything. Unless you're working for a very small company, you're going to be working in one part of the Internet of Things. But it's very important that you understand the full stack and understand the full framework under which, the context for what you're doing. So that's important in terms of our program design. As I said, we applied state-of-the-art research. So we drew on the research strengths of the staff in the school, and we built a project module that was supportive of the students at the time. We also have flexible delivery modes. So, for example, on this program, all lectures are recorded, which is important because it means that if, for example, especially for international students who might find my accent difficult, or I might be speaking very quickly initially, so there will be a recording of every lecture available after the lecture as well. So it means that we are able to make those available to all students as well. And that can help with revision or, study in advance of examinations and so on. So this is probably the slide that's most important in terms of the technical understanding of the program. And this gives a flavor. Now, this is going to change slightly for September. We're restructuring the project. The project is going to get a little bit bigger, but everything else is the same. The same choice of modules are available and so on. So this gives a flavor of what we would like students to do on this program. So in total, students have to do, in this structure, 9 modules. And these modules are made up of the green modules, which are the training modules. These would be kind of late stage undergraduate level 8 modules. And then the advanced modules are in this kind of purpley color here. And so these modules here, these feed into these modules. So for example, if you're coming into the program, you'd be strongly recommended to do these 2 modules. So the object-oriented programming with embedded systems, that's changing actually to be a new module on edge programming with Rust and C++ for next semester. So I have to update my slides. But this is going to change. We've just approved that last week, so forgive me for not updating the slides yet. So there's a new module that's just been approved here to replace this one, which is Edge programming with C++ and Rust. And that then feeds into the connected embedded systems module, which runs in semester 2. So you can see there's a link here. These modules, the programming here is important, for example, for web application development. The programming is important for example, network stack. So programming is important. So we try to build essential skills. The mathematical techniques module feeds into things like data analytics and machine learning 1 and 2, but it also feeds into the DSP, real-time DSP module as well. So we've tried to build the essential skills in here as well that you can take. So you don't have to do all of these modules. You have free choice. For example, if you've come from a strong engineering background and you have all your mathematics is up to speed, then you don't need to do this module. You might choose to do the programming instead. Or if you're coming from a programming undergraduate degree, you might decide to skip this OOP, the Edge programming module, and maybe focus on the mathematical techniques. So we give free choice for you to do these modules in a way that is suitable for you. But you can see the subjects that are most important here. Programming, Edge programming, mathematical techniques, data analytics and machine learning 1, and then there's a follow-on module, data analytics and machine learning 2. So that's quite a lot of machine learning as part of this program, and that's really important to the concepts. Wireless communication, the Internet of Things needs to be able to communicate, so we need communication. Web application development for building user interfaces that run in the cloud to present the data that comes from our IoT applications. Bioelectronics for wearable IoT applications. So if you're interested in connected health or human health and performance, or sports performance, for example, bioelectronics would be about how do you get information from humans. Connected embedded systems is core to the IoT. That's really about the building sensors that connect to cloud applications through communication stacks. Real-time DSP is about grabbing information from the environment and bringing it into your embedded environment. Data analytics and machine learning, I mentioned, this is an advanced module. You don't have to do the two of them. You could just choose to do one. But this is about really drawing information from the IoT data that you have. Network stack for communication. Security is obviously critically important to make sure that your systems can't be attacked. Blockchain is really important for disaggregated IoT. So moving the sort of having a distributed database of sensor information and traceability. And then finally, entrepreneurship is also really important, because that's about saying, well, you've got all these modules, all this technical skill that you have. How do you apply it to building a business of your own design? Or how do you, for example, enhance products within companies that you might be working for? So the change next year is that the project, this RD&I training, is going to be present. So that's going to be present next year. And the project is going to, instead of being 15 credits, is going to grow to 22.5 credits. So we're making a slightly different change. So see the way it says here, you have to do 4 plus 5. Well, next year you will do 4 plus 4 and then do a larger project. That's the plan for next year that we've just approved. So I'll update the slides and make them available. If anybody wants to email me afterwards, I can update the structures as well if they're interested as well, or Frank might provide details. So the overall structure for somebody who comes in September, this is our autumn entry. You come in, you do 4 modules. Typically this semester, in September, you will do 4 modules. You pick 4 of these from the top 2 boxes. You do 4 modules in the first 12 weeks, and that runs up until December. And then you'll do another 4 modules plus the RD&I training module. So any 4 of the modules plus this training module takes place then in the second semester. This is the spring semester. And then you'll do your project in the summer semester. So this is the 22.5 credit project. You will do that then in the summer semester. That goes from May to August. So essentially, if you begin in September 2025 and you're successful in all your subjects, you can be complete by August 2026. So roughly ready for employment in September 2026. So that's the overall calendar year. So it's a 1-year program, but it's a 12-month program. So oftentimes when you think of universities, you're thinking of, well, we don't run for a full 12 months. Well, in this program, everything is squeezed into 12 months. So it's full on hard work for 12 months, not 2 semesters. We effectively have 3 semesters, which I know doesn't make sense, but we do have that. We have 3 semesters. So everything is squeezed in so that you can complete the program within 1 calendar year. So that's it. The 90 credits, just if you want to do the maths, what I would say is, 4 modules is roughly 10 hours a week per module contact. So you're looking at 40 hours per week of work. And that will be about 3 to 4 hours of direct engagement, assignment work, self-study, self-directed study on top of that, and then going through tutorial materials and so on. So a lot of independent work, but it would require about 40 hours per week. So it is really a strong full-time, full-on program as part of the way it works, okay? The spring entry, I'm not going to focus on it. I think spring entry, we have a January entry. I'm not going to focus on that, just to say it is possible. We're setting that up, but it is possible to if you missed the September entry, and I'll run a webinar. We'll run webinars again on spring entry, or you can contact me directly if you want more details on spring entry. But I think most people who are on the call are interested in September entry. But just if something goes wrong in terms of your visa submission, it is possible to join the program in January 2026. That is an option as well. So you can reach out to DCU Global to get information on that. But I know I won't spend time on that here, given we're time constrained. So in terms of eligibility, the minimum requirement is a 2.2 ordinary degree. It has to be relevant to the program. So typically, as I said to you, this program, the MSc in IoT, We'll accept students who come from directly from an engineering, like a traditional EE or computer engineering degree, or any sort of power engineering degree, or come from a computing background, like a computer science primary degree. So providing you have 2-2, which is what we know it as here, this is called a level 8, an honors degree. That's a GPA of 2.5. That makes you eligible to apply. You also have language requirements that you need to make available, that you need to meet. There is a qualifier option, but not for international. It does not meet the international visa requirements. So the qualifier program is available, but only for students. Typically, it's only for EU part-time students. So most international students would come onto the full-time program to meet the visa requirements. Clearly, anybody who gets through this program then is eligible for a stay-back visa, 2-year stay-back visa if they achieve the master's, or and that's the ordinary exit from the program. So that's the MSc. I've given a quick overview of the MSc in IoT program, and Richard is about to take over in a second. My details are there. If you want to send me questions directly, I'll try and answer any questions that appear in the chat in a minute. But if you want to send me direct email questions, my email is there. Just let me know that you're applying for the MCTY program, because I get a lot of emails. So just derek.molloy, OLLOY, 2 O's, 2 L's, at dc.ie. And there's a link there that hopefully you'll be able to just Google. If you search for the MSc in Electronic and Computer Technology, you'll get that link on the DC website as well. So I'm going to hand over to Richard, and then I'm going to stay and be available for questions at the end too, after Richard is finished.
Thanks, Derek. There are 3 questions in there. I don't know if you want to handle them now. They're
okay. I'll look for them now. Yeah.
So if I join the MEng program, is it possible to change to the MSc program on request?
Yeah. So if you join one, it's possible, but you want to do that very early. So if you join the MSc program or the MEng program, you would need to do that ideally in the first week, or make the decision early on as to which you're going to do. Clearly, at the moment, there's a lot of similarity between the programs, so we will be able to structure that. That's okay. The exam CA breakdown for the program is roughly most modules. If you just as a rule of thumb, it's roughly 25% continuous assessment for most of the modules, and this is true of. You're going to see the same modules appearing in Richard's presentation. It's roughly 25% continuous assessment and roughly 75% terminal examination. And clearly, we have to manage things like ChatGPT and large language models and so on to make sure that our degrees are strongly recognized and credible and don't get devalued. So we have had challenges in terms of ChatGPT. So part of the sort of the level of CA is based around ensuring quality, that our graduates are able to have a quality award. And the final project, just to answer the final question, the final project, it's quite varied. In the MSc in IoT project, you would expect to have to do a project that is relevant to the IoT domain. So typically what we look, and this is true again of this, hopefully this is useful for students who are looking at the MECE program. What we try to strongly encourage is that you take modules and you learn the fundamental skills in the modules, and then you use those skills for a practical problem that you apply against. So typically that's led by the academics. They will identify a set of challenges that students need to do, and then you have to build a project against that. Typically, you have to apply new technology, the knowledge you've got from your modules to a new problem and solve it in that way. So it's a significant body of work, but it's very much supervised under the help of your supervisor, and that's the way we do it. Okay, I'll hand over to you, Richard.
Thanks a lot. Okay, so I'm Richard. I'm the chair of the MEng in Electronic and Computer Engineering. So there's a bit of overlap between Derek's program and ours, and you'll see that as we go through it. It's a level 9 award, same. So it's past your higher degree, it's a master's degree before the PhD level 10. And the way we have it structured is that it's very modular. You pick modules that you might be interested in. There's a general major award that you can get. But if you want to specialize, we have four different specialties, and they're called majors. So we have image processing, Internet of Things again, nanotechnology and photonics, and then data and telecommunications networks. And we'll come back to them in a while. All the modules that you can possibly choose are listed on that website link below. So um, a lot of people like to take just the general and then pick and choose what they want. Um, there are some restrictions as to which choice of modules you can take, and we can look at that. So we have four entry points as such. Derek was saying he concentrated about us in the September one, and we do have a January entry, and we've also got part-time and full-time. So the full-time is a September entry. It's 12 months duration. Um, so it is quite a heavy workload. It's 12 months of hard work. If you want to take it at a more leisurely pace, if you're working, for example, there is a part-time option, and that can be 2 to 3 years. Um, there's January entry, full-time and part-time as well. The full-time in January, you notice there it's 18 months instead of 12 months. That's just the way we have it structured. There's no really easy way to change that to 12 months, just the way the academic calendar is in the college. So the way to pass the course, you complete 8 7.5 credit modules and then the master's project. Now, Derek mentioned we might split the master's project this year to 7.5 credits and a 22 credit, but it's sort of the same material, just split into two separate modules. The project being a lot of work. 22.5 credits, it's like 3 full-time modules that you'd be doing, so it does take a lot of your work, and that's done over the summer. Right. We have a qualifier program. It's called MEQ, and if you don't meet the requirements to go into the masters directly, you can take the MEQ, and if you do sufficiently well in them, those modules that you take, then we accept you into the Eng program. We can talk about that offline if you want to contact me directly. It's the longest running master's program of its type in the country, which is great strength. We've got good industry contact. A lot of our people worked in industry, and we've got a lot of graduates out there. Anywhere you go, you'll meet a DCU graduate, and we do have the best employment statistics, as we mentioned earlier. The material is constantly reviewed. It's the latest and greatest we can come up with. So sometimes it can be the leading edge is the bleeding edge. So it can be hard enough to get your head around some of the complex topics that we talk about. And it changes from year to year. Case in point, we're bringing in Rust there in Derek's module. It is flexible, so you can pick and choose. Sometimes it's easier to choose a subject that you're interested in. But then if you're targeting a specific career, you might force yourself into something that doesn't come naturally to you. So it's up to you to choose your path. We can give some advice, but basically when people come to us and say, what modules should I choose? We tell them, look, you can have a look at the core modules and the majors, and if they don't suit you, then have a look at the general master's degree. There's some of our college faculties for research, Insight, IPIC Connect apps, and you can have a look at them in your own good time. But they're very leading edge centers of research. Why are our graduates in high demand? Derek mentioned the economy. We're full of high-tech international companies looking for the best graduates, and we generally place all our graduates very easily. hardware, network, software, especially. Cloud computing has just exploded, so everybody wants expertise in networking and software. Um, the graduates come out, you'll be ready to step into any role that a company can throw at you, and the project gives you good self-reliance and how to do your own research and manage your own time. That's a key element of the course, and the ties between industry and DCU are immense. The program structure is the same with MCTY. You start in September. You have to do 8 modules, so we advise you to do 3 to 5 in the first semester, 3 to 5 in the second semester, and then once you've completed them, you can move on to your project. At the moment, it's June to August. A lot of it is you'll meet with your supervisor, you'll pick a topic, you'll do your research, and then you'll start the actual experimentation over the summer. The semester 2 entry, as I say, it's a bit more stretched out, 18 months currently, might be 20 months next year. You go 3 or 4 modules, you take the summer off, and then you come in semester 1, finish off some project modules, start your project preliminary work, and then semester 2, which is January to May, you finish off any 7.5 credit modules, and then begin your project work, same as semester 1 entry. And then if you want to do part-time, you can pick 1 or 2 modules and take a number of years to complete. So that's something that if you're in industry working and you need to improve your level of education, then we advise this route. You have 4 years in total to take the whole course. The qualifier, you have the semester 1 entry, and then you take 4 modules, and if you hit the right amount of credits, then we'll let you proceed, and you'll keep the modules that you've completed and put them towards the MEC award. So, the majors that we have, the Internet of Things, you'll see it's very similar to the one Derek's described. So, and he's gone into why the Internet of Things is so big at the moment. I've nothing really to add on that, as he's the expert in the department on it. To me, it's a really interesting area of research. If I was choosing it myself, I'd go for this option, but there's other majors that we offer as well. So, image processing. We touched on self-driving cars. I think Tesla cars have 8 cameras, I think, in real time, and they've got quite a powerful computer in there analyzing the data from these cameras and trying to work out what's going around in 3D space. Other camera or other autonomous car companies, they use LiDAR, lasers and stuff, but Tesla's philosophy is that we've got 2 eyes, so we can do it all through vision. They're trying to get through to full self-driving, and they keep promising it, but whether it'll ever happen, we'll see. They might need a few more MIPS in their CPUs. But so it's all focused on how computers interact with the real world by looking at things and analyzing shapes and patterns. And you can imagine then there's a lot of maths involved in there. So we do recommend you do the maths modules and also programming, of course. So C, Rust, C++. A lot of the real-time stuff, you need to get close to the metal. So C is still there after all these years. And Rust is looking like it's going to be a worthy competitor to it. But we still bet on both legs. So in here we have core modules, which are on the left, and then the ones that build up to them, it's the flip of what Derek showed. So you have, for example, machine learning 1, and then you do machine learning 2, mathematical techniques, and then you go into the DSP stuff is very heavy on the mathematical stuff. But big interested industry for this sort of stuff because as we automate things, computers become more and more visually active. Cameras are so cheap nowadays compared to 30 years ago. They're ubiquitous. So the other one we have is nanotechnology and photonics, which is much more traditional electronic engineering. So how we design chips, how we continue to meet Moore's law. This Gordon Moore said in the 70s that computers would double in capacity every 18 months. And it's more or less proved true, but it's creaking right now. So we're always looking for new physical properties that can help us achieve new breakthroughs. So chips are generally two-dimensional. There's a move to make them three-dimensional. Silicon is sort of at the really edge now. So there's always gallium arsenide and then the new nanomaterials that are coming out, which show promise. Also, photonics are very linked to this. So traditionally, we link chips together with electrical pathways, but we're hitting the edge of what can be transmitted on a bus now. So optical connectivity between chips is something that's really hot at the moment, and moving into from the electrical to the optical gives a lot of advantages, but also disadvantages. So it's we merge the two electronics and the photonics together for this particular major, and we have a few people who are leading experts in the field. Again, you've got your core modules there, and then you've got your ones that build up to it. So, for example, bioelectronics, very interesting. Um, Energy system decarbonization. So, with data centers now taking up so much energy, we always have to think of the sustainability agenda and how we can make data centers less thirsty. Nobody's really come to a solution for that, but that would be one area of research you could look at. Then the final one is data and telecommunications. So the internet is just exploded and it's continuing to explode. It's everywhere. But how does it actually work? How do all these devices, when you click on a web page on your phone, what machine in what country generates a response, and how does that information get passed all the way across so many different various networks and devices to return in real time with some answers to your question about how many Marx Brothers there were. So that's where we're at with this. So routing protocols. So in a typical network, you'll have switches, routers, hubs, and then they'll go on to fiber backbones, and then you've got optical switches, undersea cables, space. So we have network analysis and dimensioning, which feeds into future network architectures. So traditionally, when you'd have a website, you'd have a computer serving web pages, but then that went into data centers, and then data centers got sort of commoditized. So you have virtual machines in data centers, and how all that works compared to a physical network is all what we go into in these future network architectures. Machine learning is in this one as well, and also we have network performance and data analysis. It's very hot at the moment. Everybody wants machine learning capabilities. It's very mathematically focused, so just be prepared for that if you do. And the master's project then. So at the moment it's 30 credits. We will probably pick out a few parts of this and make it a separate module, which would be a precursor module that we talked about earlier. The major part will be 22 credits. But at the moment, this is the outline of it. You pick your project, you do your literature review, you present how you're getting on, and then you get the final go-ahead to start working it. And then over the summer, you do your testing results analysis, and then you finally submit your portfolio around end of August, and then you do an interview on it. So it is a lot of work and it's very stressful. Most students like to have the summer off, so it's quite the opposite in respect to this. It is a level 9 award, so you can be prepared for some hard graft. Our entry requirements, so a H22 and a level 8 cognate degree, so engineering, computer science, applied physics. Um, and then for the qualifier, we can take a level 7, but then you do have to go through some modules and pass them at a sufficient level to get onto the MECE. And then we have the fees are there, they're indicative. They might go up. Generally, we index link them, so I'm not going to stand over those fees, but they were current at the time of writing. Um, Application deadlines, they are out of date. So um, we'll be you'll be able to apply up to September 2025 and January 2026. And full details on how to apply are in there, but we can sort you out if you have questions on that. I see questions are coming in anyway. Hey,